In this video, we like to show the possibilities for Beckhoff and Riedel communications in terms of entertainment industry applications in theaters, concert halls, stadiums, or theme parks. For this, Riedel offers an interface RRCS, which they are supporting in their artist system. In our demonstration, we also show the Riedel SmartPanels. In addition to that, we find the Beckhoff control system, which has an I/O system next to it, and also control panels with a web-based HTML5 HMI, which we can also use from different other end devices. When we look to the I/O system from Beckhoff, we show here in this demonstration only two elements, which is the LED control for a pixel LED control and the digital control of elements, but we also offer way over 1,000 more different signal types for inputs and outputs into the system. In addition to that, we also support a system for drives and motors, which is not part of our demonstration today. For the entertainment industry, we have developed over the past years multiple interfaces. We are supporting Streaming ACN, ArtNet, POSI StageNet, QSC, and also Riedel with RRCS. And we are also showing in this demonstration the integration of DNB amplifiers via the AES70 or OCA interface. As we are focusing on the RRCS, the implementation on the Beckhoff side is possible based on a basic TwinCAT license, where we add then a REST API or HTTPS interface and have certain function blocks for the programmer available so that he can communicate out of the PLC to the Riedel system without any further knowledge. He just needs to know PLC programming. Beckhoff supports various operating systems, for example also Windows, and this allows the user to have the needed RRCS server running on the controller from Beckhoff instead of having a separated server. Also, it's possible to have on our controller a Dante interface running on Windows with a Dante virtual audio card, which allows us to send Dante streams into the Riedel system. We are using that in our application here to generate error messages. We have a software tool called TwinCAT Speech, where we can take written commands in the controller, which the programmer is writing. That can be error messages, that can be alerts, that can be information. And we take this written information and transport it into speech. And this is what we see now.
Caution, switching cabinet B, circuit breaker F2 tripped.
So we have generated an error proactively, and then we have an error message written in the system, which we then transported via Dante to the Riedel system and hear it on the speakers. So this command can also be then sent to the correct group of people, so that we have different groups in the Riedel system and only the right people will hear it. We have also a second error we can generate, and then we hear a completely different
Caution,
message.
switching cabinet A, circuit breaker F1 tripped.
So we had cabinet B and now we had cabinet A, so there's different messages which you can put in the text and have them sent out via TwinCAT Speech. TwinCAT Speech supports different languages and also the possibility to have not just plain text, you can also have variables in the text, which means you can have the height information of an object in the theater or temperatures or other variables which you anyhow have in the system because you have the sensors or motor information and can take this information and transform it into a voice message. The other applications we are showing here are related, for example, to the amplifier here. So we have buttons here on the Riedel system where we can push these buttons and then have a change in the mute state of this amplifier. We can do the same also from the Beckhoff device, where we see on the Beckhoff device the status, but also have the possibility to have the same interactivity. And this can be done in a hierarchy or groups in certain layers, where you can define that in the logic of the PLC, which element should be when active or deactivated, and so on. The next use case is the control of light elements. So we have the control of pixel LED, for example, which we are showing here. So we have a pixel LED matrix which we can control that can be in different sizes, that can be LED stripes, that's any type of WS28 pixel LED. And we can control that with different colors that can be complete colors or also each pixel is individually controllable, so we can control each pixel. We can also then combine that with digital signals about, okay, for example, this is my off button, which is somewhere in the theater as a classical light switch, yeah? And then I'm activating it again. I have another off button maybe here on the Riedel device, so that is all possible in whatever hierarchy and combination you like to have it. The other thing is that we can also dim elements, so there's also the dimming possibility out of the system with certain different controllers. So we have the dimming possibility here, or also from the Beckhoff device. That's the same. You can build hierarchies and architectures about that. To sum it up, the end customer or system integrator has the possibility to control the system over either control panels from Beckhoff, smart panels from Riedel, belt packs from Riedel, integrated light switches in the theater, or other control possibilities, and also extend the system with the other possibilities which Beckhoff is offering for stage machinery, building automation, and light control. We have realized a couple of projects already worldwide, and we are happy to support you.